Witches and Warlocks of Weather, it's Prof G, and we are going to get meteorological in this lesson and build a weather app. Now, this lesson actually is a midterm solution for my class at Boston College. This lesson shows a series of challenges used on an in-class 2.5-hour midterm. After each question, I'll demonstrate a solution. The exam is given live on laptops, and students can only use help in Xcode itself, as well as a single double-sided page of notes that they can prepare in advance. The goal is to be somewhat restrictive, to make sure that students are prepared for technical interviews, and to make sure they're not learning copy and paste coding. Now, in this exam, we're using the free open-meteo weather API. If you're wondering why I didn't use Apple's Weather Kit, the purpose of the exam is in part to test students' ability to call an API and access JSON. And I specifically wanted complex JSON with nested values that also included some arrays. Now, the app also saves preference data using SwiftData because our students learn SwiftData, and I wanted to challenge them on that as well. Now, this app doesn't identify your location or offer place lookup simply because we haven't gotten to that point in the course yet. We will, though. And while this video is a bit less polished than my standard learning-focused lessons, I hope you enjoy it. I hope it's a good challenge for people that are following this as independent learners. Welcome to learners from other universities and other institutions. My best to your teachers and classmates. Drop a note in the comments and let me know where you're from. For the students who took this exam, I hope you did well. And for students in my current classes studying this before future exams, good luck. Now let's get swifty. Now in the description of this lesson, you'll find a link that will take you to a PDF version of this exam if you want to check it out. You can also pause the video and read the question on screen if you want. The first question asks you to set up a new Xcode project named SwiftYweather and download the resources at this URL and properly add the app's icon and set up the launch screen. So I've launched Xcode. We're setting up a new iOS app. It's called SwiftYweather. I'm going to save mine to the desktop. Now I'll click on Assets in the Project Navigator and I'll click on my app icon. I've already downloaded the folders from the URL mentioned. It's in the SwiftYweather files. I'll drag the weather icon and plop it right into the app icon space. I don't have a dark mode or a tinted icon, and I'm going to highlight these 3 sizes for the launch screen and drag them into the side of the assets catalog. And we know from our previous lesson, in order to get that launch screen to show, we have to click on the project icon at the top of the project navigator. We'll click on the info tab and find the launch screen area, expand that. I'll click the little plus circle at the item that's indented below launch screen, select the image name option, and then you put the name of the launch screen file in the value. For us, that's just launch screen, all one word, all lowercase. Then select a device to simulate, click play to build and run, hammer time, of course no errors, we're just starting our app. We see the launch screen show up, and if we click on the home button, we can see the icon as well. And you don't have to do this, it's somewhat controversial, but I'm going to right click on the SwiftYweather folder and I'm going to convert that to a group. I'm a creature of habit and I like to drag my folders around so that they're in the position they used to be in earlier versions of Xcode. Now let's code. And I also asked students to change the name Content View to Weather View, so we'll highlight Weather View in the struct definition line, right-click, select Refactor, rename, type Weather View, and press Return, and I'll also change the Weather View in the comment line up here too. Now the question says all of you should be in a navigation stack, and we're going to do that because we're going to add a toolbar to this as well, so I'm going to embed the VStack in an HStack, since there's not an embedded navigation stack, and change HStack to navigation stack, and we're done. Now the question says that the views should be listed vertically with no spacing between them, so right after the VStack we're going to add parentheses, then add the spacing parameter with a colon followed by 0. And to make this work, I'll get rid of the padding below the VStack. Up next, we want an image in here with cloud.sun.rain.fill. I'm going to highlight and delete this text view and the modifiers. I forgot the .fill, but I'll fix that in a second. To take up the maximum available space without distortion, we'll say resizable .scale to fit. And to add horizontal padding, we just say .padding passing in .horizontal. Then we'll add a text view with a temporary string, wild weather, and we'll set .font to .large title. Then below this we'll have another text view. We'll set our placeholder temperature to 42, which fans of Hitchhiker's Guide to the Galaxy know is the ultimate answer for life, the universe, and everything. To type the degree symbol on the Mac, that's going to be Shift Option 8. I'll put in an F here for Fahrenheit, but this is just a placeholder. This will all change when we get API data, and below this I'll set my .font, and I'll set the size by saying .system, passing in a size of 150. And the question also wanted you to set the .font weight to .thin. And one more text view that says wind 10 miles per hour dash feels like 36 degrees Fahrenheit. at .font.title2 with some dot padding at the dot bottom. And as mentioned, I wanted cloud.sun.rain.fill, so I'll change that. Next up, we want a toolbar with the gear in the upper right-hand corner. Remember, our toolbar has to be inside the navigation stack, so I'm gonna double-click on the opening curly brace for navigation stack, and I'll put my .toolbar, open and close curlies, just inside the navigation stack, closing curly, so it's inside the navigation stack, not outside. Then I'll add a toolbar item view with placement and content in here. The placement is going to be .top bar trailing, tab press return for content for trailing closure. Inside, this is going to be a button with an action and a label. For the action, I'll put in a to-do comment that says add gear, click here. And the label is simply going to be image with system name, passing in all lowercase, the word gear. Next up, we want a color behind all views that's cyan at an opacity of 75%. Everything in the view should see the color behind it, including the toolbar. Then we want to change all the views, including the gear button in the upper right-hand corner, so that they are displayed in the color white, except for the image, which we want to be with the multicolored option. Not all symbols support the multicolored option, but cloud.sun.rain.fill does. Now, in the very first app that we built for this course, we learned that we could put a color behind everything else by leveraging a Z-stack. So I'm going to embed the V-stack in a Z-stack. Then above the V-stack is the first item inside the Z-stack. Remember, Z-stacks stack top to bottom. The first item will be the very bottom item. I'm going to say capital C color, passing in .cyan, setting .opacity to 0.75. And below this, very important to get it to show up in the toolbar area, I'll say .ignores safe area. Now to get everything in the color of white, below the curly that closes the V-stack, I'm going to say .foreground style, passing in .white. This doesn't get our gear button in white though, so we need to add just below the button the .tint modifier with .white. Remember, we use .tint here since this is an interactive control. But we want to get that image to show up in multicolor. So up here as a modifier under image system name, I'm going to say dot, and remember it's symbol rendering mode, passing in .multicolor. Looking good. Next up, you want to create a view model to handle API access and JSON parsing. You should call this weather view model. You're eventually going to populate this with all the values, datas, and data structures and functions for API access. First, create a variable named URL string. I gave you the URL string to use. Then do what's necessary to get the following JSON. From current, you want the values temperature underscore 2M, apparent underscore temperature, weather underscore code, and wind underscore speed underscore 10M. Then you want to map those respectively to variables that you should create in the weather view model that have the names temperature, feels like, wind speed, and weather code. I ask you to write a function getData, which gets the data from the URL string. Do what's necessary to execute getData when the weather view screen first displays. And I advise you that it's a good idea to simply access one data element, say the temperature underscore 2M, and print it out just to make sure that you get data access working properly, then build the remaining data structures. So I'm going to put my weather view model just below my SwiftUweather app file. I'll right-click on SwiftUweather app and select new file from template. This is going to be a Swift file. It's not a Swift view. I'll call this weather view model, all caps, then say class, weather view model, open and close curlies. I'll add the @observable macro above. Then I'll head back to the exam and copy this entire URL string and set var URL string equals, and in between quotes, paste this in. Now we'll also head to a browser and paste this in so I can take a look at the JSON. All my students learned how to add a JSON extension to either Safari or Chrome. Again, you can check out the playlist to learn how to do that if your JSON isn't looking nicely formatted like this JSON is. Now the values we want to get are inside of the current key. That's where, just like the question mentioned, you can find the temperature 2M, the apparent temperature, the weather code, and the wind speed. So we need a data structure that's going to get variables that have this exact name. Since all of these guys are inside of a key named current, spelled with all lowercase, let's head back over to our view model, and we can call this first level of our JSON that we're getting anything, but I'm going to say struct capital R returned, which is what I usually do. I mentioned that in the lessons. This has got to be colon codable, open and close curlies, and inside we'll say var current. Critically important, it's got to be spelled exactly like the key value in our JSON, and it is. And we'll say colon, and we'll say capital C current afterward. Now we could call this data structure anything we want, but typically adding a capital letter for the name we want to use as the data structure is fine. So below this I'm going to say struct capital C current colon. This is also codable, always critical to make sure that your data structures are codable. If you don't do that, you're not going to be able to parse the JSON. And then in between curlies, I'm going to say var, and I'm going to hop over to the web browser to copy the names to make sure that I don't get any spelling errors in here. I've got temperature underscore 2m, which is colon double, then var apparent underscore temperature colon also a double, var wind underscore speed underscore 10m colon double, and var weather underscore code colon int. This is an integer. Then back to the browser, I'm given 4 names that I want to use as variables that I map these values parsed from JSON into. So I'm going to copy these 4 names, head back over to Weather View Model, paste this in, make sure the word var is in front of all these variable names, and I'll set the first 3 equal to 0.0 since they're doubles, and the weather code equal to just 0. Now it's time for our getData function. So much of this is standard, so we'll start off with func getData. Open and close parens will pass nothing in. This is going to be an async function, open and close curlies. I always print out the URL string first, so we'll say print, and in between double quotes, we'll put in the web emoji so that the string is easy to find. Then we are accessing URL colon string interp passing in URL string. Now a little iOS weirdness, we can't make the API call with a string, we've got to convert it to a URL data type, so we'll say guard let URL equals URL, selecting the string option here, passing in URL string, else open and close curlies, we're going to return, and above that we'll say print angry emoji. We get an error in here, colon, could not create a URL from string interp URL string. Hopefully you will never see that. Then down below we're going to make a call to URL session. That could potentially throw an error, so we'll put that in a do open and close curlies catch open and close curlies. We know that gives us back a tuple of 2 values, so we'll say let, and in parentheses, we'll get back the data value, calling it lowercase data, comma, and we don't really care about the response, so we'll put an underscore character in here. The response is just a code. We won't do anything with any codes that come back. Then we'll say equal. Since this throws, we need to say try in here, and it's also an async function, so we'll start this with await, and then we'll enter URL session dot shared dot data. We want the option with from in here. We're going to pass in the URL. Notice code completion as expected. This is an async and throws, and it returns a data and URL response. We pass in lowercase URL, the URL we created above from our URL string. Then down below, we're going to try to decode the JSON into our own data structures. Now we're going to decode from JSON. This could also potentially throw an error, but we're not going to do this in a do try clause. Instead, we'll just say guard let returned. You could call this variable anything, but we'll create a constant called returned. Set this equal to try question mark since it's in a guard statement, and we'll say JSON decoder open and close parens dot decode. We want this option with type and from. And it looks like Predictive Code Completion guessed properly for me here, but just to point out, remember returned.self is this value that we created up here. It's the first data structure that's getting data back. We get that from data. Else, if something goes wrong in here, well, we've got a return, and above this we'll print out another error statement, but we'll change this to angry emoji JSON error could not decode return to JSON. Now if the guard statement lets us through, we've got our JSON. So I'm going to say print, and in between double quotes, the cool emoji, JSON returned exclamation point. And in string interp, I'll just pass in the returned value so I can see my results print out. And if this doesn't work, we want another error statement down here in the catch, which should be print error could not get data from URL string is fine. I could also print out an error localized description, but I've skipped that here. Now before this will work, we've got to head back over to our weather view. And remember, we want to call that getData function as soon as this view loads. So I'll collapse our navigation stack, and just below this, now I could use an onAppear, but because this is going to be an async function inside here, I'm going to say .task open and close curlies. If I use .onAppear, I'd have to include a capital T task open and close curlies, but I'll save that extra step. And oh yeah, I can't call getData in the weather view model until I create an object, an instance of the class weather view model. So up top I'll say at state var, I'm going to call this lower camel case weather VM, set it equal to upper camel case weather view model open and close parens. That initializes, creates an object of type weather view model. Then down below I can call await weather VM.getData. Parens are at the end because this is a function. I'm not showing anything print out, but if I click on the play button to build and run in the simulator, I can see everything's looking good and the JSON is returned. It shows my current temperature value, the apparent value, the wind speed, and the weather code. You probably have different values in here because you're accessing this at a different time, but either way, we know we've got our getData function working properly. So now that I know I've got my API call returning JSON, I'm going to head back over to my weather view model. And I want to put my return to JSON values into these 4 variables that are part of my class here. So I'm going to copy them And down below my guard let statement, I no longer need this print statement with the cool emoji in here. I'm going to delete that and paste in the 4 values that I just copied. Get rid of the var out front, and then I'll set the assignment. So temperature is going to be equal to return.current.temperature_2m. Feels like is going to be returned.current.apparent_temperature. Wind speed is returned.current.wind_speed_10m, and weather code equals return.current.weathercode. And now that we've got our data, we can head back to our weather view and expand our navigation stack and make our changes. We no longer want wild weather in here as this text. Now we're eventually going to want to have a value or a string that's returned from our weather code, but right now I'll just print out the weather code. So in between double quotes, I'll put in a string interp and print out weathervm.weathercode. Now I'm going to change my 42 for my temperature to inside a string interp weathervm.temperature. And look at that, we can see some data over on the right, but we need to make some changes. First, let's change our wind speed to string interp, and where that number was, we'll pass in weathervm.windspeed. And we'll change the feels like temperature to string interp weathervm.feelslike. Now all of these values have decimal places because they're doubles. We want to convert them to integers. Very easy to do. I'm just going to click on all of these variables, and with a value highlighted, I'll press the open paren, a closed paren is added, then I'll left arrow and type int on all these values, and look at that, our results come from our API call. Our data is parsed, and it's in our weather view. Nice. Now up next, we have to add functions to get the weather description and the icon from the weather codes. Now those codes are from the WMO, that's the World Meteorological Organization. I've written 2 functions that you can use. You can get them at this URL, and you should put them in an extension of the weather view, and then call those functions get weather description and get weather icon where they're used so they properly show the icon, the image, and the description based on the WMO weather code returned. So let's click this URL, and we'll head to our browser, and we'll click on plus to open a new tab, paste in the URL, and there we see our functions. Let's highlight both of those functions, copy them, head back over to Xcode, and then we'll scroll to the bottom of our weather view, and we'll add our extension with extension, weather view, open and close curlies, and then just paste in the 2 functions. We didn't have to put them in an extension, but these functions are so big, they take up a lot of space, we know they work. Putting them in an extension like this is a nice way to organize your code. So we can see we've got 99 cases plus a default case returned. There are actually 100 cases because I guess there's 0. So let's scroll back up here and we'll replace our system name, getting rid of the string literal cloud, sun, rain, fill that we have in here, and instead we'll simply call get weather icon. It wants us to pass in an int for the weather code, and we know we've got that, so our 4 value is going to be weathervm.weathercode. And look at that, friends, as I am recording this lesson, it looks like we got a partly sunny day here in lovely Chestnut Hill, Massachusetts. Then in the text view below this where I'd printed out our weather code integer, I'm instead going to call get weather description, and I'm going to pass in the same thing, weathervm.weathercode. And the weather description says clear sky. Every once in a while you see a discrepancy with the data. If it's a clear sky, I don't know why it's not just the sun instead of the cloud and sun, but I'll take it. Up next, there's some advanced JSON parsing. So what we need to do is we need to go inside of the daily key, and we're going to get 4 arrays. One named time, another weather code, another temp2m max, and another temp2m min. Now once we return this data into arrays, we want to map them to class properties we're going to create called date, daily weather code, daily high temp, and daily low temp. And I ask you at this point simply to print out the 4 arrays when getData is called, and it should look similar to the values below, but you're of course going to get different data because you're processing this at a different time. So just to verify, if we head over to our browser to take a look at the JSON returned, we previously got values in the current key. Now I'll compress some of these keys, and if we head down here to daily, we want these other values. And look at the ones that we've got in here. We have time, and we can see that there are square brackets around it, so this is an array. Same for weather code, same for the temperature at 2 max, and the temperature 2m min. That's what we want, so we're going to need to create a struct named daily, and then inside this, we're going to have a time, weather code, temperature 2m max, and temperature 2m min array. It looks like time is a string, the weather code is an int, and the other 2 are doubles. So let's head back over to Xcode, and in our weather view model, we'll create these new structures. Below my current struct, I'll say struct capital D daily, colon, this is codable, open and close curlies. And up in my return structure, since daily is at the first level of my JSON, just like my current, I'm going to add a new property to my return structure that says var daily : D daily. And then back in that daily struct, I'm going to say var time : and then in square brackets string equals empty square brackets. So this will create an empty string array named time, and I'll do the same below for the other values. Var weather underscore code : square brackets int equals empty square brackets. Var temperature underscore 2m underscore max : in between brackets double equals empty square brackets, and then var temperature 2 underscore min : this is a double array equals empty brackets because it's empty. So now we've got this daily property getting these 4 arrays inside of the daily struct, but we don't want to have to go inside of this key value to get the values that we want. We'll create 4 properties at the root level of our class. So down below weather code, I copied the 4 variable names from my exam. I'm going to paste them in. I'll add var out front of all these variable names. And then I'll set the value types. So date is : an empty string array, daily weather code is : an empty int array, and the daily high and daily low temp are both empty double arrays. Then I'll copy these 4 array variables that I just created. Then in my getData function, I'm going to head into the do portion of my do catch clause, and underneath where I assign the other variables, I'm going to paste in the 4 variables that I just copied. I'm going to get rid of the var statement in front, and I'll set these to the appropriate data structures that our JSON decoder coded our values into. Date is going to be equal to returned.daily.timed. If you option click on time and date, you can see they're both string arrays. That's exactly what we need. Daily weather code equal returned.daily.weathercode. Daily high temp equals return.daily.temperature 2m max. And daily low temp equals return.daily.temperature 2m min. Then we'll just print out these 4 arrays below: the date array, the daily weather code, the daily high temp, and the daily low temp. When we build and run, we take a look down below, and we're getting the result we expected. Nice. Up next, we're going to head over to weather view, and in here what we want to do is put a list view down below that's going to allow us to scroll and see all 7 days of our weather forecast. So we're in question 11 now. We want to add data to the list. We want to take the 4 lists of data that we received and add them to a list view. Put that below our last text view in our weather view. The first element is an image represented by the WMO weather code. Then we show that date string and the daily high temperature / daily low temperature. Everything in Title II font except for the daily high temperature, which is in the title font and bold weight. All values are also top aligned. And when it's working properly, it should look like this. So let's build. Now I want to add my list below my last text view, but I also want to cut out the foreground style .white below this because I don't want my list text to be white, at least not while I'm configuring this initially. So I'm going to paste that foreground style white modifier below the views above. And now I can enter my list below this. I'm going to select an option with data, ID, and content. Now, since I have multiple arrays in here, I can't iterate through a single array. So what I'm going to iterate through instead is a range. And we've seen this in our class exercises. So I'm just going to say 0 ... less than symbol weather vm .dailyweathercode.count. All our arrays are the same count, so we could get a count of any of them here. My ID is going to be \self, tab over, press return for trailing closure format, and we're going to call the value we iterate on index. This is just going to be an integer. And the first value that we have in here is going to be an image with system name, and the system name is going to be the result of the getWeatherIcon function call. And we'll pass in weathervm.dailyweathercode and in brackets index. So what this is going to do is it's going to go through each of the elements of our array, 0 through whatever the count is for the daily weather code array. Each of those values is going to be an index. Let's assume it's 0 through 7. Then for the image system name, well, we get our system name by calling our getWeatherIcon function. For the array element that is weathervm.dailyweathercode, add an index. So we're passing in a number from 0 to 99 that we got from our JSON call, but we're getting back from this function a string that we can use to show the appropriate system name. And if we look over here on the right-hand side, we see a nice little image showing up in our list. And I'll set the list style to .plain so it looks better. Then below this, I'll add a text view passing in weathervm.date and in brackets index. And these are below each other, so I'm going to wrap these in an H stack. Then I'll put a spacer below this and another text view below that, and that's going to be the string interp, degree symbol, capital F, space /, and I'm going to pass into the string interp weathervm.dailylowtemp in brackets index. We can see this value has lots of decimals, so I'm going to wrap that in an INT. And below this, I'll do something similar with text, and that's going to be the string interp passing in the int and in between parens weather vm.daily high temp in brackets index. This is looking good. Everything in the HStack should have a .font of .title too, so I'll put that below the HStack except for the last text view. That should be in .font .title in .bold. And we want everything to be aligned up top, so we're going to add another parameter to our HStack call up here. So in between parens after HStack, we'll say alignment : .top. And this is looking good. We've got all of our arrays showing up in our list. And next we want to replace the date shown in the date array with the day of the week. Now those days in the forecast are going to start one day after the current day, and in fact we don't even need the date array that we got. Instead what we're going to do is we're going to write a function that does the following. We're going to get a requested date by adding the number of days to the current date. So for example, a code below shows that it can take an integer named value and add this to the current date, returning a date of value days in the future. Once we have that date in the future, so we would go through our list of, say, 1 day in the future, 2 days in the future, all the way through 7 days in the future, we want to get the day number. 1 is Sunday, all the way through 7 Saturday. Remember, there's not a day 0 in here. That's important for indexing. Then once we get the day number, we can return the weekday by using calendar.current.weekday symbol and passing in whatever that value is. And now that you know how to do this, you should be able to write a function called getWeekday that takes in an int value. Imagine iterating through the range like you're doing. And you want to return the current weekday name for that day. Once you've written that function, you want to call it in your list so that the correct day of the week replaces the date array. And you see an example of what things should look like if everything's working properly. So I'll write this function at the top of my extension saying func get weekday, and I'm going to pass in value : that's going to be an int, and then arrow, I'm passing out a string, open and close curlies. And most of this function is written for us. So over here in the exam, I'm just going to copy this first line where we get the date value, paste it into the top of the function, so whatever value I pass in, this is going to give me the date of however many value days there are in the future. So again, that'll just increase the date by value days. Then we want to find the day number, 1 equals Sunday through 7 equals Saturday. That's this line over in the exam, so we'll copy it. I'll paste it back into our function, and just so we can see what's happening here, I'm going to print out day number equals string interp day number. Then we want to convert the day number to the weekday and return that string. So this little chunk here will return that weekday. We'll paste this in, but very important because the weekdays are 1 through 7, but we want to get an element in an array. We want to get 0 through 6. That means you should subtract 1 from this value. I notice a couple of folks making this error and not noticing why they had an index out of range. Remember, always use print statements if things look mysterious in your code. They can be a huge help. So this will return a value. We could either return this right away, but I'm going to say let weekday equals this value, and I'm going to print out, oh, how about I change this and do this on one line? So I'll print out day number, string interp, weekday, string interp, put the day number and weekday number in here, and I can get rid of this print statement above. Then I can just return weekday, and my function's done. And now to call this, I'm going to head up to my list, and my second item here is the first text view. I'm going to get rid of the weathervm.date index, and I'm going to replace that with getWeekday, passing in as a value index. Whoop, I got a little error in here. And again, remember, if we want to go a certain number of days in the future, we don't want to start at 0, we want to start at 1, so I'll add a +1 in here. So the hardest part about that was getting the 0 indexing to match up with the 1 through 7 weekdays, but it's looking good. Hopefully you got that, and if not, hopefully you now understand how to handle those indexes. Now just to polish up our interface here, and question number 13, a real easy answer. I tell you exactly what you've got to enter, even though you've never done this before. .list row background, passing in color .clear. We'll make sure that those rows of the list are transparent so that the background color bleeds through and everything looks like that nice 75% cyan. So this is for the list rows, not for the list. I'm going to paste this in as a modifier for my HStack down here, and we can see the colors bleeding through. Nice. And to set everything inside the HStack to white, we'll just add a .foregroundStyle.white above this, and you are looking weathertacular. Next, you want to create an enum named unit system that we'll be using to select the different types of unit, either imperial for the US or metric. Very important that the enum is created in a way that makes it accessible to all views in the project, so it should be outside of any class or any struct. You didn't have to put it in its own separate file, but that's what I'll do. And the two cases should be .imperial and .metric. And very important, since you're going to use this with SwiftData, you've got to make sure that it's codable as well. So back in Xcode, I'm going to right-click on my SwiftUweather app file and select New File from Template. This is going to be a SwiftData file. We should name this Unit System, one word, upper camel case, since this is a type. Then we'll say enum unit system string case iterable codable open and close curlies, and predictive code completion actually enters the two values for us. I'll put them both on one line. You didn't have to do that, but the fact this is in a separate file, and really more importantly the fact that it's outside of any struct or class, means that this is going to be accessible everywhere in our project. Now up next, we're going to create a preference view. It's a new SwiftUI view named preference view, and it should look like the image that I show below. All views have standard padding around all elements. There's a variable location name, which is used in a text field. Descriptive text, location, and title font. Use the standard rounded border style and add some additional padding below that view. Then we want two text views, latitude and longitude, that are labeled in standard font size bold, and below each we're going to have text fields with rounded border style that allow the user to enter two variables, latstring and longstring respectively. We'll add additional padding underneath the bottom only of the text field displaying longstring. Then we're going to add the code to create a units picker shown below. Specifically, the left side should say units in bold, and the right side should have the picker view with the pull down to expose the values imperial and metric. Note the capitalization. Those should be taken from your unit system enum. The value of the picker view selection should be stored in a variable named selected unit, with imperial being the default case. Everything in this row, the text view and the picker, should be title 2 font, and then below that we want to add a toggle labeled show F/C after temp value. On the left and on the right it should have the toggle view that defaults to being turned on. You want to keep track of the values selected from the toggle in a variable named degree unit showing, and all those values should also be in title 2 font. Then below this we want to have another text view with the value 42 degrees in standard font size 150 points. And when the show FC toggle is switched off, the F or the C value in the 42 degrees should not show F or C, but when it's checked on, the 42 degrees should show either F or C, depending on whether it's imperial or metric selected in the picker view. There should be a navigation bar at the top of this view that says cancel and save. Again, a properly set up preference view should look like this. So I'll create my preference view by right-clicking on my weather view. New file from template. This is definitely a SwiftUI view. We're going to name this preference view. And this build is pretty straightforward. So we'll start off with a navigation stack, open and close curlies. Inside, we're going to add a text field with the title key and the text. But in order to be able to add some text in here, we need to create a variable up top at state private var. I mentioned that we should call this location name. We'll set that to an empty string initially. While we're at it, why don't we say at state private var latstring equals empty string, and at state private var longstring equals empty string. Then down below, the title that we're going to pass in is prompting text in our text field is going to be the string location, and our text is going to be the binding $ location name. Also set the .text field style to .rounded border and the .font to .title. We'll also add some padding below the navigation stack, add a spacer down below. And above the spacer, still in the navigation stack, we'll add the text label that's going to be latitude, and that's going to be .bold. And below this, we'll add our other text field, which is going to pass in the prompting string latitude, and the text is going to be saved in $latstring. Then I can copy these two views, the text and the text field, paste them down below, but change the second text to longitude, and the second text field prompt string to longitude, passing in the text $longstring. Now we can see we're not aligned left, but what we can do is make sure that all of these views are inside of a VStack. After the VStack, we'll have open and close parens. We're going to pass in the alignment parameter, which is going to be .leading, and then surround everything in open and close curlies. Now the alignment's looking good. I'll put the padding below the VStack, not the navigation stack. Below the text field, I'm going to add some .padding .bottom. And all four of these views that I've highlighted here should have the same font, so I'm going to cut them out and put them inside of a group. Then below the group, I'm going to say .font passing in .title2. Below the last text field, I'll pass in .padding .bottom as well. And below this, we're going to have our picker view, and we're going to have a label to the left of this. So I'm going to put this inside of an H stack with open and close curlies. Then I'm going to add inside of this text, which is units, and this is going to be in dot bold. And then below this, I'll add a picker view. I want one with a title, selection, and content. The title is going to be the empty string. Remember, the standard pull down picker doesn't show a title on iOS. Tab over to selection. Oh, and we need a selection value for this. So up top we'll say @state private var selected unit equals, and we want to set this to default to imperial. So we'll say unit system.imperial. Then down below, pass in $selected unit, tab over, press return for trailing closure format, and we want to enter a for each in here with data, ID, and content. The data is going to be unit system.allcases. The ID is going to be \self. Tab over, press return for trailing closure format. We can call this iterated value anything. I'm going to call mine unit. Then inside this, I'm going to say text unit.rawValue. And over here in the preview, we can see we want the picker to be pushed over to the right. So I'm going to put a spacer in between the text and the picker. And you know what? If I was taking this test, I'm working too fast here, I would have lost a point because I'm supposed to capitalize that raw value. So you should have put .capitalize after it. Then below this H stack, everything should be in .font, .title2. So down here, we're going to add a toggle. And for the label text, we'll say show f/c after temp value, but we need a value for the is on. So we got to head back up here and we'll say @state private var degree unit showing. We'll set this equal to true. Add $degree unit showing down below. Let's remember to add a padding below the picker view at stop bottom, and also to increase the font size of the toggle to .title2. We'll also set that to bold. That's looking good. Then below we'll have that temperature value in a text field, so that's going to be 42 degrees F, and that's going to be in font system size 150 and font weight of .thin. I'll put that in an H stack in here because I want to center this. And I'll put a spacer in front of and behind this, so that pushes that to the center, looking good. Now there are a few ways you can handle changing this F to a C or an empty string. Some of you might have put a string interp in here and written a function. What I'm going to do is I'm going to actually create a computed property. So up top I'm going to say var degree unit : it's going to be type string, open close curlies, and this is going to return, a string, so initially I'm going to say empty string in here. But above this, I'm going to say if degree unit showing, open and close curlies. And on the next line, I'll return string interpolation with return selected unit $imperial ? Capital F string : capital C string. That means if the selected unit equals imperial, I'm going to return an F. Otherwise, I'm going to return a C. But if the degree unit is not showing, I'm going to return the empty string. Nice. Then I can head down here, replace the capital F with string interp passing in degree unit. Watch what happens when I change my units. And toggle the show FC after temp value on or off. Everything's looking great. Up next, we're going to save these preferences values using SwiftData. So you should create a SwiftData class. We're going to save the preferences data above to a SwiftData class named preference. This class should have the following properties: location name defaulting to an empty string, lat string, long string, also defaulting to empty strings. Selected unit should be the imperial case of the unit enum. Degree unit showing should be true. And it says do everything else necessary in the project so that we can take advantage of the class. Also, I want you to create some mock data for the preview, the same way that we learned in our earlier exercises. Now we only need one record in here in our mock data, so we're going to use location name Dublin and the lat string longitude that I gave you. Metric is the selected unit, and the degrees showed should be true. So let's do this. So I'm going to create a preference Swift file underneath my unit system. I'll call it preference. Now, since this is going to be SwiftData, I'll import SwiftData. I'll say @model so that I use the model macro. Say class, preference, open and close curlies. We'll add main actor up top, and I copied the different names for the values or the properties that we should put in this class, pasted them in, and let's make a change. We'll put var out front of all these property names. Then set the first three to empty strings. Selected unit, I'll specify that as : unit system, and set that to equal .imperial. And the degree unit showing will be true. Then I'll create my initializer with init and accept everything that's offered here. Now, one thing I'm noticing is that the select unit did not specify a default value in here. I'm going to want to change that later on. Also, for some reason, I'm getting an error up here in selected unit. It doesn't seem to like the fact that I've specified this as a unit system and then just used .imperial. So I'm going to get rid of the unit system : and just put unit system in front of .imperial, and the error goes away. Now to create our mock data, I like to do that in an extension at the end. So we'll say extension, capital P preference, the name of the class, open and close curlies. And we're going to do this by accessing a static variable that we call preview, and we'll use that in our preview container. So I'm going to say static var preview : model container, open and close curlies. So this will be a computed property named preview that I can access from model container, and because it's static, that means that I can access it without creating an instance of this class. Now let's create that container internally. We'll say let container equals try exclamation point, and to create the model container, we'll say model container. We're going to select the option with 4 in configurations in here. Now the 4 is where we enter the model. That's just going to be our capital P preference.self. So that says we're going to create a container with the characteristics that we created above in this preference class. And for configurations, when we tab over here, we're going to say model configuration. We're going to create a new one. We're going to select the option with is stored in memory, and we'll pass in true for that. So again, this is just mock data. It's only used in the preview so that our preview doesn't crash and we can lay things out, and I'm going to return the container variable I just created below. And now what we need to do is we need to populate the container with anything that we want to use as mock data here. I'm only going to put in one record. We do this by saying model.mainContext.insert, and then we're going to pass in a new preference instance, and I'm going to select this option with all of the different parameters for preference. If I hold down option and press return, I get an option to enter all these parameters as part of my initialization. And here's a tip. Well, I could enter all this on one line. Sometimes it's easier to see the parameters on separate lines, and if you want to do that automatically, Xcode can reformat things if you type Control-M. So this is the same initialization statement for preference, but it's on separate lines with a parameter on each line. It's just a little easier to read. It's up to you if you want to use this. Then I gave you some sample data to use for the mock data, so it's going to be Dublin, Ireland is the location name. I'm going to copy and paste the longitude and latitude from the exam. The selected unit is going to be unit system.metric, and the degree unit is going to be true. So again, if the computed property confuses you, what's happening here is we're creating a property named preview, but instead of setting this equal to a value, we're computing what should be inside of it. Internally, we're creating a little constant called container, and then we're stuffing it with stuff inside of this preference. Then when we return the container, it goes inside the variable preview. That's how we learn to create mock data. That's what's going on here. And remember, I mentioned that one issue with initializing the unit system up here, so I'm going to set my unit system equal to unit system.imperial just so that I pass in a default value, and now all the values have defaults. Now we also need to make some modifications to our apps file, but first I'm going to head over to my preferences view, and since we're going to use SwiftData in here, we want to import SwiftData up top. And we always create an environment variable for model context. So we'll say @environment, passing in between parens, \model context. This is a private var named model context. And while we're at it, why don't we also create our dismiss variable here @environment between parens \dismiss, private var dismiss, so that we can exit this view when we need to. Now let's modify our preview so we can take advantage of that mock data. Below the preview preference call in the preview provider, I'm going to say .model container, passing in capital P preference .preview. And we've got nothing showing up here yet, but we'll change that. And you know what? I skipped over adding the toolbar with cancel and save in here, so let's add that now. I'm going to collapse the VStack, and I'll add it below this. I'll say .toolbar, open and close curlies, add a toolbar item with placement and context. The placement's going to be .toolbar leading, and press return for context, trailing closure. I'm going to enter the button with the title and action. The title's going to be cancel, the action's going to be dismiss, open and close parens. Then I can copy the toolbar item, paste it down below, and modify this. Down below, the placement for this is going to be .toolbar trailing, and this is going to be the save button. And for now, I'll just add a to-do comment in here saying add save code here. Now next up, we want to implement SwiftData in our preferences view, and we've done some things for this already, but we also want to create a variable preferences that will query and keep track of the array of preference data that we save. Now I give you the hint in here that says previously we've dealt with arrays of data in SwiftData, but here we're only going to save one element or one value of preference to that array. I also remind you to set up the model context. We've already done that. Now when the view first appears, we want to check to see if anything is in the preferences variable. We've done this, and if there is, then we want to take that first element of the preferences array and assign it to each property of that element to the appropriate variable of the preferences view. So those are the variables that are inside the interface element, again, just like we did in our to-do list, or when we worked on Friendsgiving, or when we worked on our places I've been. The only thing that's different in here is we want to take one element out of that array, and again, I tell you exactly to do that. Now, when the cancel button is pressed, we'll make sure that we dismiss. We've already got that in there, but when the save button is pressed, we should do the following. Since we don't want to save more than a single element to the preferences model, we should loop through all elements in preferences if the array is not empty. Again, I give you a big hit there too, and we should delete all of the values in the array. And we can use the same technique we used to delete previously. It's just model context delete. Same stuff we did before without swiping. Again, you get a hint here too. Then we want to pass any local variables in the user interface views into a new preference instance. And then we want to save that, again, the same way that we learned previously with our insert. And once we've done that, we can dismiss the view. So let's code that up. So first up, we're going to query our preferences SwiftData style, the same way we've done before with @query var. We'll call this preferences : and this is going to be between brackets P preference so that it gets an array of preference data. Again, we're only going to save one element, but we'll deal with that in a bit. Next, just as we've done before, when we first read in that preferences data, we want to assign that to local variables. Now, the only difference here, I warned you about this, is that we want to assign the first element in the array if the array exists. Well, we know that we are able to grab the data as soon as a view appears by using a .task modifier. That's the same as .oddAppear with a task inside it. So let's head to the closing curly in our navigation stack. We'll say .task, open and close curlies. Now, if our preferences is empty, we don't need to assign any variables in here. So we can check with this by saying guard preferences.isEmpty, else, and in between curlies return. But the guard condition is if the preferences is not empty. So we want to fall through and do some stuff if the preferences is not empty, assign variables. So we're going to put an exclamation point in front of preferences.isEmpty. The guard will return if that's not true, but if it is true that the preferences is not empty, then down below we're going to find the first element of our preferences array. So we'll say let preference equal preferences.first exclamation point. It's okay to force unwrap this because we know based on the statement above that preferences is not empty. It's not going to give us a nil error. Then I want to assign these 5 state variables up here to the value that I'm getting from that preference constant that I just pulled out of preferences.first. So I'll copy these, paste them down below. If I command control and continue to click across the start of the 5 variable names, I've got a multi-line selection in here. I'll backspace to get rid of the stuff in front of the variable names that I don't need. And I'll set each of these variables equal to the preference equivalent. So preference.location name, lat string, long string, selected unit, and degree unit showing. Now let's head up here and add our save code. And before we do that, we've got to do some SwiftData setup in our app file. So we'll head over to the SwiftyWeather app file. Again, we've done this many times. You know, you've got to import SwiftData. Then down below our first view, we'll add the modifier .modelContainer, selecting the option 4, and we're going to pass in our model as P preference.self. And we also enter a special init in here. And the reason that we do this, and again, you don't have to do this for the test, but it's always a good idea, is that this will print out the application support directory that we can use in order to find the data that's stored in our simulator, and we can interrogate that with DB Browser, just to make sure everything's saving okay. Again, this wasn't required for the test, but I always recommend that folks do this. So we'll say init, open and close curlies, and inside we'll print, and in between parentheses, url.applicationsupportdirectory.path, and for the %encoded option, we're going to pass in false. Then we can head back over to our preference view. And as I mentioned, we want to make sure that we save only one element. So we're going to delete all others before we save. And by the way, I should mention there are other ways to accomplish this other than dealing with the arrays. But we'd previously worked with arrays when we read data in. So I think this is the way that our students should use based on what we've learned so far in class. If anybody used another technique that worked completely, I would accept that for full credit. And if you want to share a technique you've used, feel free to drop knowledge in the comments. Now, if my preferences array is not empty, I want to make sure that I delete all that data first. So I'm going to say if preferences.empty, open and close curlies, but I'm going to put the not symbol, the exclamation point, before preferences. And if the preferences is not empty, let's loop through all the elements. We can do that with for preference in preferences, open and close curlies. And inside, all we need to do is say model context.delete, passing in the preference. At this point, we've got nothing saved to data, so let's create a preference to save based on the values that have been entered into our user interface element. So I'm going to say let preference equal P preference. I'll hold down the option key as I select the option with all of the different variables, press return, and I'm going to control M so that all those variables are on separate lines. It's just easier to see. Then we'll pass in those local interface variables, location name, lat string, long string, selected unit, and degree unit showing. And if we have all this, well, all we need to do is to insert this value. We do that with model context.insert, passing in the preference constant that we just created. And you don't have to do this next bit, but this is good to use if you intend to interrogate things with DB browser because it forces a save. I'm going to say guard let underscore equals try question mark model context.save and open close paren. Else, and in between curlies, we'd return, and above that we'd print out angry emoji error save on preference view failed. And that should never occur. Hopefully we'll never see that. Now we've already got our dismiss in here, so let's take a look at question 19. So in order for this to work, we need to get to the preferences view from the weather view, and we want to do this when we click on that gear. So we're going to do this by setting up a full screen cover sheet. Again, it works just like presenting a sheet, and we're going to launch that from the preferences view whenever the gear is clicked in the navigation bar. And at this point, we should be able to build and run in the simulator. I also mentioned if you add the little bit of code in the application support directory, then you should be able to find the file that includes the default store file where you can interrogate things with your DB browser. Remember, nothing is saved, not even a preferences file, until you actually save data on screen and refresh. But I give you some sample data that you can use here if you want to test some things out. Previously, we had some Dublin data. Here's some data from where I'm located at Fulton Hall in Chestnut Hill, Massachusetts on the Boston College campus. So let's try this. So we'll head over to Weather View, and whenever we work with a sheet, we always create a bool to determine if it should be presented or not. So up top, we'll say @state private var sheet is presented and initially set this equal to false. Then down below in our toolbar button for our gear button, we can get rid of this comment in here and we'll change this to sheet is presented .toggle. So you click that gear button, false is going to turn to true, but we got to create the sheet. And I want to do that outside the navigation stack. How about right below the .task here? So I'll say .full screen cover. Select the option with is presented and content. Is presented is bound, so it's going to be $ sheet is presented. Tab return for content in the trailing closure format. And this is going to simply be preferences view. Nothing's passed in, so just open and close paren. And this should work. We can try it out in the preview, and we can see the sheet is presenting properly, but if we want to actually save data in SwiftData, we should click on play to build and run on the simulator. Hammer time, no errors, that's what we want to see. Things are up and running. Your data might look different because you're querying this at a different time. We can see stuff's printed out in the console. And yeah, there's still a bunch of changes that we need to make in the interface elements. You can see that I forgot an F behind the high temperature for each of the elements in the list view. But right here, I'm concerned about saving data in SwiftData. So I'm going to scroll up to the top, and I can see that URL for the application support directory printed out, just like we've done in examples in our learning videos and in class. So I'm going to highlight this. Then I'm going to right-click on that URL with the whole URL highlighted. I'm going to say services, open. I get this option to confirm that I want to run service. I do. This opens the directory where I've got my default store. This is where the simulator is saving data in the application support directory. So I'm going to right click and select open with DB browser. Again, we learned how to do this in our earlier video lessons. We can head to browse data and preference, and we shouldn't see anything in here. But now let's head back to the simulator, click on the gear, and here's our preference view. I'm going to enter the data that I gave you earlier for Dublin, Ireland. I'm going to change the units to metric. I'll click on save, and as mentioned, I don't see the change happen yet, so that's what we're going to do in the next question. But if we head over to DB browser, I'll click on refresh, and oh, look at that. We've got a record saved for Dublin, Ireland. Cool. Now, if I head back over to my app, and let's change this in the gear again. How about location name? Now it'll be Narnia. Then I'll head back to DB browser. I'll refresh, and we can see it is indeed only saving one entry for preferences, which is perfect. It says Narnia in here, so our save with SwiftData is working fine. Now let's get that data to load. So I'll change my data to Dublin. I'll head back into the simulator and load things up in the preview again. So again, we're mentioning that nothing is loading in except for the preferences data that we have up here. But for question number 20, we said we want to read any changes in the preferences data and use this to make a new API call, retrieving and displaying data. Now, in order to use preference data in our weather view, you need to use SwiftData, and you know how to configure a new view so that it can use SwiftData. You want to read your preferences data into a value named preferences that contains an array of preference objects. And note, given how you saved your data, you should only have one single element here. So before calling the API to get data, what we want to do is we want to see if there are any values in the preferences array, and if there are, we want to change our URL string as follows. The location after latitude equals in that string should be replaced by using the lat string that we retrieved from our preferences data. The longitude should be replaced by long string. The value after the temperature unit equals should be replaced by the string Celsius if it's the metric unit system, or Fahrenheit if we've selected the imperial unit system. The value after wind speed unit equals should be replaced by kmh if the metric unit system was selected, or mph if the imperial unit system was selected. And I said it's critical to get the spelling right. It's kmh, not kph. That's an easy mistake to make. I suggest that you print out the URL string after you make changes, just so that you can verify how things are looking, and hopefully that you have a valid URL string that you can use in a browser. And another important note, at this point, you won't see any changes after saving data from the preferences view and returning to the weather view. But if you quit the simulator after saving data in the preferences view and then rerun, you should see new data used when the app first runs. Here's how things should look below. So let's go ahead and build this up. So back in Weather View, let's set things up SwiftData style with import SwiftData, and then to query things, we're going to add an @query var. We'll call this preferences : and this is going to be in between brackets preference, because this is going to get back an array of preference data, although we should only get at best a single value. Now also to use SwiftData, we want to say @environment, and in between parens pass in \model_context, which is a private var we always call model context. And now let's make sure that we map the preferences data that we read in into our URL that we're about to call. So down in our .task call, we'll say if preferences.empty open and close curlies, but we want this to be not, because what we're going to do is we're going to grab the first element of this array that we read in, and why don't we put this in a preference variable. So up top, we'll create an @state private var preference equals P preference open and close paren, so that we initialize this. It's got nothing inside. And now that we've got a variable to put our first element of the preferences array in, let's head back down to our task, and in this if clause, we'll say preference equal preferences.first ! It's totally okay to force unwrap this because we know that this preferences array is not empty. We will never get a nil in here. And if this is the case, we're going to modify our weather vm.url string, setting this equal to, and I'll put open and close quotes in here. Then I'm going to copy my URL. You can either copy it from the exam or from the web browser where you open the JSON. You also previously pasted this string in your weather view model class. Paste it in here, and let's modify it based on the data that we got back from preference. So as mentioned in the test, you want to look for the equals values in here, and you want to change them. So let's see, I can start with longitude in here, and I'll change the value that was in here to string interp, and then in the string interp I'll pass in preference.longstring, and then I'll do the same thing with this latitude value that I have up here. Delete that. Make sure you don't delete the and symbol in there. You want to keep that ampersand in there. But again, inside the string interp, this is going to be preferences.latstring. And let's see, some of these we can ignore, but we want to change the temperature unit equals, and in here what I'm going to put in before the ampersand is another string interp, and in here we either want to pass in Fahrenheit or Celsius, again as the exam question stated. So let's put Fahrenheit or Celsius in here by using a ternary operator inside of the string interp. So we'll say preferences dot select unit double equals dot imperial here, and if this is true, question mark, we're using our ternary operator in here. So if this is true, we're going to pass in the string Fahrenheit. You want to make sure that you spell that exactly correct like this, colon. If that's not true, then we want to pass in the string Celsius, spelled just like it is here, lowercase. And finally, we're going to do something similar after wind speed here. We'll say inside the string interp preference.selected unit double equal sign dot imperial question mark. If this is true, we're passing in the string mph colon. Otherwise, if it's not true, we're going to pass in the string kmh. Remember, it's mh and not ph. Now I went ahead and built these changes all at once because I've done this a few times. It's probably a better idea to make one change at a time to make sure that your URL string works properly. As is always recommended, it's a good idea to go ahead and print out our weathervm.url string to see how things look. I actually should have printed it out before the await call, but actually it's also being printed in our get data, so we don't have to worry about that. Let's build and run and try things out. Oh, we're seeing some different data in here now. This data is coming from Dublin, Ireland with a different latitude, a different longitude. Now look, I've also got metric selected down here. I've got to make some of those changes in my UI. The F isn't changing to C, and also we're not responding to the show FC after temp value toggle. But why don't I change the data back to Chestnut Hill, Massachusetts, and I have the longitude and latitude that I can grab from my exam. And again, the location doesn't do anything other than let me know as a clue where I put the longitude and latitude in from. But when we save this, we're not going to see any change. The exam mentioned this, but if I go back to Xcode, stop the simulator, then rerun, and oh, we see different results in here. It's a little warmer in Chestnut Hill, Massachusetts at this time than it was in Dublin. Now we see some other UI changes I want to make in here because it's still saying a big F in here instead of a big C. What happens if I head into Preferences and I change to Imperial Units and then launch again? Oh, we can see that 7 degrees is 45 degrees Fahrenheit. Nice. Let's try Preference Changes again. Head back to metric, head home, swipe up to get rid of the app, relaunch it again, and we can see that we've got 7 degrees in here. This is actually Celsius, even though it says F in here. Now we got a few more updates in here. For question number 21, it says we're almost there. The problem is we're not recognizing when the preference data has been changed, but we know how to do this using Swifty skill. We can recognize when the preferences value has been changed. Big hint, that means an onChange modifier. If that happens, then we can call the same code that you set up previously that checks the preferences array, reads it in. If there's a first value, then we can read that value in, update the URL string, then call the API accordingly. You even get a little recommendation in here. It says since the code that you're using to detect a change in preferences is the same as the code that you'll use if the app first loads, you might want to try putting this into a single function, perhaps called callWeatherAPI. And you can call this whether the app first loads or if the preferences value changes. And if properly implemented, we should now notice that the weather view immediately changes when you've saved data in the preferences view. Those changes will show up as soon as we get back to the weather view. Let's make it so. So back in Xcode, I'm going to highlight all this code that's inside of my task clause, cut it out. Then I'm going to put the function, how about down here in the extension? That's a good place for it. So I'm going to say func call weather, open and close parens. I don't have to pass anything in. Open and close curlies, paste in all that code that I just cut out. Oop, I get a little grump in here because this function has to be an async function. Now the error goes away. Then in the task clause, I'll call weather API, open and close parens, and Xcode always reminds me, hey buddy, you gotta put the await in front, so I'll do that. The error goes away. Then we want to do the same thing if we have a change of our preferences variable. So just above this, I'll use a .onChange modifier. I'll select the option with of and just the action parameter. So when the preferences changes, I'll change this so that it's in the trail enclosure format with the curlies. What I want to do is simply call await call weather API open and close parens. Now Xcode gives a little bit of grumpiness in here, but just like we could wrap other values that called an await in a task clause, we can do that here. Not .task, but capital T task, open and close curlies. We'll put the await inside, errors go away. Let's build and run, friends, and see how things look. So we got 7 degrees showing up in here. This is actually Celsius or metric. Let's swap this to imperial, save moment of truth, and oh, we see it switches to 45 degrees because we've updated the URL string. The API is called. We get back the other data that's parsed in JSON and put into our UI. Cool. Click that gear again. Change back to metric. We see the temperatures now shown in metric. Nice. Now for our very last question, we've simply got to make the final UI updates so that things change as expected. If the user's turned off the toggle that says show FC, then that should not show either the big F or the big C after the degree symbol. And if the user has selected the toggle, we want to show either the F and the appropriate wind speed for imperial or metric. We describe how to do that. We show how things should look. So let's finish our build. And first, I notice in the last value in my list, I don't even have the F symbol in here. Now I can add the F symbol, but what I really want to do is I want this to show either F or C or nothing depending on what I've set up in preferences. Let's start making those changes from the top. So I'm going to highlight the F that I have here in my big temperature, the one that's the size of 150 points. And now some of you might have put a string interp in here and written a function. A function is totally fine, but I want to show you that you can also use a computed property for this. Again, I didn't tell you use a computed property, but I want to show you this as an option. It's a very Swifty technique, so it's good for you to know. And I'll call this variable, it'll be a string that's either a capital F, capital C, or an empty string by saying var, I'll call it degree label, colon, string, open and close curlies, and I'm going to start out by returning an empty string, but I'm not always going to return an empty string. Up above this, I'm going to say if preferences dot degree unit showing, open and close curlies. Then I'm going to check to see if preferences.selectedUnit double equals dot imperial, open and close curlies. And if this is the case, I want to return that capital F string, else I want to return the capital C string. So again, look what this is doing. It's a variable in here that's going to return a string, and it checks to see if we want to show a degree. If we do want to show a degree, then we check to see if it's the imperial unit. If that's the case, we return an F. If not, we return a C. But if the preferences degree showing is false, we skip down to the return and we send back an empty string. Now let's use this bad boy. I'm going to delete the F that I've got in here in my big temperature, put in a string interp, and then I just refer to the variable in here, degree label, no parens afterward. It's just going to calculate the value in here because it's a computed property. I see a big F showing up over here on the right, and I'm going to use my degree label variable down here in my list view. I've got these two text views for the daily temperatures, and here we go. We're going to get rid of the F and put in a string interp degree label here, and then in that last one, string interp degree label. And let's see, where else do we have a capital F in here? Oh yeah, up in this line in the text view that has the wind speed in here. So I'm going to do the same thing up here, string interp degree label. And we want to do another change for the MPH. Another thing we could do is we could just put a ternary operator right inside of the string interp. I'm going to do that right now. So in the string interp, I'll say preference dot selected unit double equals dot imperial question mark, and that'll return the string MPH colon. Otherwise, we should show KMH. Friends, this should work. Let's go ahead and build and run. And ding dang, will you look at that? We have the big C for Celsius showing up in here. We also have our wind speed as 7 kmh. What happens if we click that gear and say that we should not show the FC after the temp value? Click save. Ding dang, friends, the F and the C go away. We just have the 7 degrees showing up here, looking good. What if I go back into the gear and change to imperial units? Click save. Ho, 7 degrees becomes 45 degrees. All the other date values are updated, looking great. We also have our miles per hour for our wind speed. Let's try toggling the FC back on again. That looks great. And you know what? I'm going to try a different location in here. I'm going to put in Dublin, Ireland. Again, the name Dublin, Ireland doesn't show up any place, but I'll put in the same latitude and longitude that was in the test. This is going to be metric. I want to show my FC value. Let's click save and see. And oh, that is magnificent. It's overcast and 5 degrees Celsius in Dublin. Stay warm, Irish. Let's hide that C value. Look at that. The C goes away. And friends, I wanted to make sure that we had a better icon that was updated here, so I'm going to change the location to Amsterdam, and I copied the latitude and longitude for Amsterdam, so I'm going to paste that in. And you know what? Amsterdam doesn't show me any changes, so I paused here and I looked around for something that was different, and I found that Vienna had some activity, some precip in there. So I enter the values for Vienna, and we save this, and oh, look at this. We got moderate snow at 6 degrees. Now, this is 6 degrees Celsius. It actually surprises me we're snowing because we're above freezing. We can head back, and we can show the imperial units in here. That's 44 degrees Fahrenheit. We shouldn't be getting snow with that. But everything is otherwise looking great, so hopefully you did well on this exam. The retake option is available for my students because if you take one of my classes, the goal is not grades. The goal is to make sure everybody leaves as an app developer. We've got a no coder left behind policy. Everybody should be able to pass. Hopefully the concepts were described well here. You've got these concepts in other videos. We also covered them in class, so there should be lots of notes on Keynote slides too. But if you have any questions, feel free to come and see me during office hours. We want to make sure you're prepped up for your final exam, which will continue to leverage these topics. You can almost look at this as a test drive for our final. We want you to be ready for that. Swifters, keep hacking. And also, once you update this build and you get everything working right, post it to GitHub because this is a great thing to have in your GitHub portfolio. Take some screenshots of the app, maybe put an animated GIF in there, and show folks all of the different techniques that are being used here. API access, JSON parsing, complex API access with nested values and arrays, SwiftData use, lots of sophisticated user interface updates. Swifter, you should be proud of everything you're learning. Continue to hack.